Hey, good morning, everyone. Jacob and I are here to talk about some MFA stories that we've had along the way. So, over to Jacob.
Kia ora everyone. For those who don't know me or don't recognize me with this moustache, I guess you could call it, I am Jacob Hawthorne. I work for Bastion Security Group out of Wellington. I'm an offensive security consultant and I specialize in the cloud space. So if you're interested, come have a chat afterwards.
Yeah, I'm Dave Carrot. Work with Jacob, hack the pens and do our sort of stuff as well, and do little things like run KakiCon and make stickers and stuff. So if I film around, I'm most sure I got stickers in my pockets, or you send them around on the desks. Cool. So what are we going to look at today? So we're going to do a little bit of the background, look at some MFA implementation issues that we've seen, some issues in web apps, some issues in cloud, and a little bit of a rack up at be looking at what you can actually do to have something robust when it comes to MFA and whatnot. So what we'd like people to have sort of at the end of this talk is why you should be using MFA, some common mistakes that people do, so how to avoid them, and how to implement a robust authentication system with MFA. So a little bit of the background: two-factor authentication, multi-factor authentication, two-step verification. They're all subtly different if you get down into the weeds, but so the purpose of this talk, just assume that they're synonyms pretty much. And when we talk about factors, there are factors which are something you know, like a password. There's something you have, like your U2F YubiKey, your card, your phone app, and there's also something you are, your biometrics, your fingerprints, your iris scans, your face scans. Yeah. So why do we need MFA? Why isn't usernames and password enough? Well, people reuse their passwords. They think, I've got one secure password, I'm going to use it on everything. I'm going to use it on my email, my banking, my corporate account, my some forum, shopping site, whatever. But the problem is there's multiple breaches every year where attackers will get the credentials from some site over here, My Little Ponies forum or something, and go and use it, and that's the same password as they're using on their banking or on their email. Some vendors are actually quite good at keeping an eye on breaches and actually telling their users when their user has been in a breach and maybe they should change the password for their own security. I think we've seen Logbean's done that after LinkedIn, MySpace, and Tumblr breaches. And browsers are also prompting now, if you're using a breached password, if you're using the browser password manager and other password managers, they're telling you when you've got a breached password or your password's been in a breach. So sort of as we've said, that people are reusing passwords. Some of these other sites, they might not be hashing the passwords, so they just throw it in the database in clear text. They might not be using salt, or they might be using peppers, so you can easily crack them. Or they might be using weak hashing error that's really fast to run through a password cracker. So it makes it easy. And, most of them aren't following, like OWASP has a cheat sheet on how to store passwords. A lot of sites that we reviewed don't actually follow that advice. So MFA to the rescue. They do that. There's now push notifications on your phone and to stop some of their attacks that we've seen with fatigue attacks. Microsoft now has to type in that number because there was a problem previously where an attacker would get in and they just spam the phone with these push notifications and just assuming that at some point someone's going to give up and go approve because this notification keeps popping up, or the kid who's on their phone just wants to keep playing their whatever game they're playing, and that the notification problem's just in the way. And then we've got the YubiKeys, which are coming quite common. Lots of people have seen them, hopefully. They'll tell you plug into your laptop, and they've got proof of presence, so you actually have to touch them for them to work. So even if you leave it plugged into your laptop the entire time, it's not an issue because someone saw its physical presence to actually touch the capacitive thing to make the key work. Now, they're a little bit more costly. They're hard for the user to misuse. They have proof of presence. Most browsers and operating systems are now starting to support them. And it's not quite here yet, but we are seeing more of it as sort of the passwordless and passkeys, the WebUFOIN, these are like TPM on the laptop back with the fingerprint, U2F with pins, and just sort of add this extra robustness. We're starting to see it, and that's sort of a good long-term roadmap and some of the terms that you should be heading towards in the longer term, and ties the log on to the device. So, we've got MFA, and there's still some ways around it, We can still fish it, so we can make a malicious page that looks like the Google login field. For instance, you'll type your two-step verification in, and you get this. And there's Evil Gen X, which basically just automates the entire process for you. You basically point it at a log-on screen or log-on process. It bakes up a dummy website for you. It captures all the cookies and the session data and gives you a little session data that you as an attacker can put into your browser and browse as that user is all logged in. So what are some issues that we've actually seen with web application implementations? One of the big ones is places that only allow a single multi-factor authentication at a time. So I've had one, so this has the problem that if you've had like a time-based one-time password, the codes that rotate every 30 seconds, so you go, I've now got a U2F token, I'm going to upgrade it, and you actually find that you have to delete MFA to go and add U2F. Or you go, another recommendation is when you've got those tokens, you have a primary and you have a backup. There are these sites that only allow you to have one key registered, and that really makes the recovery, the break glass, how you're going to recover from losing the token or having a phone die. You've got to make sure you allow multiple types to be enrolled, or multiple instances on the same type to be enrolled at the same time. The one in one-time password is really important. So we had this logon field, it was using JSON. So when the user logged in, it would send a username, a password, and an empty OTP field. When the server saw an empty OTP field, it would go off and send a text message to the user with the one-time password. The user would then get that additional field on the logon form, type in the one-time password, and it's the same JSON field, but this time just with the one-time password filled out, login success. Problem was that as an attacker, if I managed to get the one-time password and sometime later just skip that first step and just do the JSON request that had the username, the password, and the one-time password, the server would just lock you in because you provided all three pieces of data. Weren't worried about sending it to you because I didn't see a blank one-time password. So the important part here is one-time passwords need to expire after use. They should have a limited time window. You shouldn't be able to use them for like the next day, for instance. Another issue that we've seen is the seeds for things like the time-based one-time password should only be displayed once. This means that if there's a session takeover attack, you can't just like browse through the page, see the QR code, scan it into your thing, and no one's aware of it. You want that session hijack attack that you need to require the attacker to actually make another TFTP system so the user can see, hey, wait, that is more phones than previously registered, and when someone has to generate a new QR code, it'll quite often send an email saying, hey, we've added a new multi-factor authentication. If it wasn't you, you might want to check your settings. So make sure you only show it once if someone needs to re-sign up, just show them another QR code and maybe offer them their ability to delete the previous one if they've lost that phone or something. And sort of following on from the sort of QR code system is, I had a system that a colleague was testing. They had a login form, had an MFA prompt. That's all good. If you just use the username and password and you try to directly browse to one of the pages in the application, it'll go, oh, you're not fully logged in with multi-factor authentication, redirect you back to the logon form. Problem was, if you directly browse to the MFA setup screens, after typing in the username and password, it didn't actually redirect you back to the logon screen. So we could add new MFA even though they've set up MFA. So what was happening here was, they had RBAC, role-based authentication over most of the app. That was all solid, worked well. But because when they're developing, they went, oh wait, first use, they don't have MFA, on that first login, they're going to need to set up MFA. They'll put it in a slightly different access group and put some different access controls around it. So it only required a username and password to access this part of the application. And so that was because of that first login thing. So what you need to do here is, hey, if it's truly the first login, yeah, sure, you only need the username and password, but if they've already got MFA set up, make sure that you actually need MFA to go and add more MFA. So I'll pass over to Jacob now to look at some issues on the cloud side of things.
Yeah, cool. So switch gears a little bit here. We're going to look at some of the issues that we've seen in cloud environments, some of the misconfigurations that can occur from blue teams, and then some of the kind of attack paths that we can use from a red team perspective to kind of get access without having to, input MFA. So a little caveat here is that while these are titled as issues with cloud, we're going to focus specifically on Azure and Entra ID using conditional access policies. It's just easier to kind of build out a scenario and showcase the gaps. These gaps can exist in other cloud environments as well. They're just simpler here. Another caveat with this one is Microsoft are actually doing a lot of work to ensure that MFA is applied to all users across the board. So they're doing a slow rollout at the moment to try and stop these gaps here. Knowing Microsoft, they will probably introduce more. So take that as you will. So if we're looking at conditional access policies, what are they? You might say I refer to them as CAPs. It's just a shorter way of saying conditional access policies, so I don't have to keep saying that all the time. This is what they look like. In their simplest form, they are just if-then statements. So we have this section here, which is our if statement in our policy. And our if statement can target our users. These could be all the users in our environment, guest users, or specific groups if we want to. We've also then got our target resources. These can be your SSO applications, Microsoft applications, or any kind of custom application that you're building in your tenant. As well here, we've got network as well, so we can geo-lock some of our access requests to certain IPs or locations. And then we have a bunch of other conditions in here where we can select different devices that we want to target and things of that nature. So once we have our if statements configured, we've got our then, and these thens can be a grant policy. So if our authentication request matches something in our if statement, then we can grant that access. We can grant with additional verification, being MFA, or we can block access as well. There's also session control there, but we can ignore that for now. Some other caveats with conditional access policies that we need to kind of understand for this one is they are applied at the authorization stage, not authentication. So they're not tied to the then statement is not tied to the user specifically. It's tied to what they're requesting access to. This is important here. We're going to use this to bypass some of these policies. With all of the checks that we define in our if statement, they all have to be met before the then statement is granted. So this is really important. If you create a really complex policy, you can create more gaps as well if the authentication request doesn't match everything in your policy. Furthermore to this, conditional access policies are not applied in order. So they're all applied if a policy matches a request. So if we have, for example, here like 26 active policies, and we have an authentication request or authentication flow that matches 20 of those policies, they'll all apply at the same time. So they can create some complexity as well in our environment. Again here, unlike firewalls, they are allowed by default. So if our authentication flow doesn't match any of these policies, then we'll be allowed access. So let's get into some of the fun stuff. What are some of the gaps we see and how can we abuse those? So the first one we'll talk about is the user agent bypass. So our organization wants to require MFA for all of our users that access any of our applications from a Windows device. So as engineers, we go ahead and we create a policy. It looks something like this. We target all of our users logging into any application from a Windows device, and we want to require MFA for that. Cool. So how does our conditional access policy know what device we're actually using? There's this thing called the user agent header. Essentially, it's a HTTP request header that gets passed from the client to the server, and it contains a bunch of information. It looks something like this. So in this string, we can see the browser that we're coming from and that version, so Mozilla. We can see that the operating system as well and the version. So we can see there Windows 10, and we can also see what device we're coming from, Windows 64. So how do we abuse this? Well, the user agent is passed from the client to the server, and we control the client. So let's make a change to our user agent header. Maybe we want to come from a Windows phone. We update our user agent header. We say, oh, yep, we're going to authenticate from a Windows phone. Now, because of our user agent header not matching a Windows device, we don't match that conditional access policy. And they're allowed by default. So we bypass that policy or that requirement for MFAs. So why does this happen? Some of you might recognize this image here. It's been categorized, I guess, as survivorship bias. Just briefly, in World War II, there were a bunch of airplanes that went out in dogfights. They would obviously suffer some damage, and when they came back, the engineers would have a look at those damages. They would see where the bullets were hit. They would reinforce those areas. They'd send planes back out. The planes kept coming back with the same bullet holes, and they're wondering kind of what's happening here. The problem with this is that they were protecting the areas, or they were protecting the areas that got hit by bullets for the planes that came home, not the ones that didn't. So they actually needed to reinforce the areas that didn't have any bullet holes. So how can we fix this or stop this from happening? Well, the first step is to not consider any client-controlled information in our security check. So we shouldn't trust what the client is telling us to allow that, or to create a security policy around it. We need to protect against the things that we do have, as well as the things that we don't have in our environment. And there's another check that we can do for devices. It's called filter for devices. This is much stronger. We'll go into a bypass for this as well, but it is better. So the other one here is the Azure Management Tools bypass. So our company wants to create a strong policy for our administrators. So they ask us to make sure that all administrators accessing the Azure portal, where all of our infrastructure is, are required to present MFA. So as engineers, we go ahead, we create this policy here, and we target Microsoft admin portals. So all users, because we want to make sure we've got coverage, right? Logging into Microsoft admin portals will require MFA. This seems okay. Why is this an issue? Well, the Microsoft Admin Portals Cloud app doesn't consider all of the management tools or all of the ways that we can interface with our infrastructure stored in Azure. We can take a look at some Microsoft documentation and see this big flag here. For those who can't read it, it essentially just says that the Microsoft Admin Portals doesn't include any Microsoft Graph API requests or anything to the Azure Resource Manager. Let's dig a little further. What does it say about the Azure Resource Manager? Well, if we include the Azure Resource Manager API, that does not target the Graph PowerShell modules or the Graph API. Okay, a little further into the documentation, what does it say about Graph API? It just says this: when you use Microsoft Graph API, you agree to the terms and conditions. So if we don't include the Azure Resource Manager API, what are we missing out on? What are the things that we can interface with as an attacker bypassing the MFA for this policy? Well, there's a couple here: Azure CLI, Data Factory, DevOps, Azure PowerShell. You get the idea. Oh, wait. Sorry, there's actually more as well. Yeah. All right, what about the Graph API? What happens if we don't include that? Well, by default, there's a couple in here. Bookings, Calendar, Delve, Excel, 365 Compliance, Discovery, so forth. There's enterprise mobility and security, advanced threat analytics. We've got some other Windows services, and Dynamics is in there as well. So not too many, right? How do we fix this? Like, what do we have to do to make sure we're covering all of these applications? Well, what we can do is we can ensure that all of the admin cloud apps are included in our policy. So we'll go ahead and we'll put in the admin portals, the Azure Resource Manager, Azure Credential Config, Azure AD Identity Governance, AD Reporting, and any application that we have in our environment that uses the Graph API. So any SSO application or any custom application that uses Graph API. But still, thank you, Microsoft, this is not enough. So completely disregard that. The best way to protect against this is to target all cloud apps. Even if we include everything before, there are still bypasses with using Graph API essentially. So moving on, trusted devices. Our organization wants to allow single-factor authentication for our users that come from a corporate device that is enrolled and managed by our organization. So engineers, we go ahead, we create this policy targeting these devices. All users log into any application coming from any device will require MFA, but if they come from a corporate enrolled device, they don't need MFA. So how does that conditional access policy know if a device is enrolled? Really simply, there's a different sign-in flow that can happen, and it will trigger an event that will essentially enroll a device. This is what that looks like in the portal. They can be registered or joined. Those two things are different, but for this talk, it doesn't really matter because we can bypass either of them. So how do we abuse this? Well, the default settings for devices are insecure by default. They look a little something like this. Any user in the tenant may join a device to the into Enter ID, and they also may register any device without Enter ID. Okay, maybe we need that. What else is there without MFA? So, according to this, we can enroll a device with single-factor credentials into the tenant. We can enroll any device with single-factor, and because of our policy, once our device is enrolled, we meet that conditional access policy that allows single-factor to every other application. So we've essentially now got a trusted device in the environment without MFA, and then because of that trusted device, we can now access any application also without MFA. So organizations try to reduce the MFA requirement on their users. It's not that hard, Julie, it's 2024. We shouldn't be making these kind of exceptions. And again, Microsoft creates some insecure defaults. So how do we fix this? First, we should check our device settings and make sure they are secure by default. And we shouldn't trust enrolled devices as a second factor authentication. Because even if that device is compromised or stolen, well, now the attacker has the second factor. So we should always be requiring another strong factor, U2F tokens like Carrot talked about. So with all of this, it can seem kind of scary. What can we do? The simplest way, well, I've adjusted, I guess, Occam's razor here. Sometimes the simplest conditional access policy is the most secure. We need to create a secure default, that baseline policy. So we can create one policy that targets all users accessing any application from any location or device. And from there, if we need to create exclusions or custom kind of policies, we can exclude them from this baseline and make a custom policy. That ensures that if we create a gap in one policy, we'll always have something to fall back on.
So just some other little things like mitigating phishing. You know, there are the non-phishable methods. There's the WebAuthn, there's the FIDO2, there's the U2F token. So this means that if someone has evil Nginx, you can't just, because in this case, the actual process in the web browser is tying their authentication back to the domain, and when it goes back to the token, it provides the domain, and that's all included. So if the phishing model on page is not actually on the real domain, it's not going to get the data back. So there's ways of mitigating the phishing aspect. I think, as we've said, always use MFA. One of the big issues previously was, it's going to be too much friction for the users. They don't want to be prompted for MFA all the time. Now with Entra ID and these other sort of single sign-ons, you're only having to be prompted every 30 or 90 days for the MFA token. That's not actually too much. And in some cases with tokens and refresh tokens, it will actually last a lot longer. And they might also need to type of thing in a new device. They might need to MFA, or they do some impossible travel. So these days, if you're sort of in a single sign-on environment and you've moved to Entra, the friction isn't actually there that it was previously. So you're not going to get that user pushback anymore. And so as I said, as we move single sign-on, this is quite good. We now, instead of having to implement MFA in every application, we go, if we use single sign-on with Entra ID, Google Workspaces, something like that, it's now a configuration problem. We just need to tick the text box and set up single sign-on across all of our applications, and we manage the MFA in our identity provider. And you're not having to make code changes if you detect an issue. And quite often the Optas, the Microsofts, the Googles, they have a better understanding about what the good authentication patterns are. They keep abreast of all the new standards and methods, so they can be integrating that into your platform and you're not actually having to do that work yourself. And as we look forward over the next few years, look for password lists, look for passkeys. These are extensions to the sort of the single sign-on that we're seeing in device enrollment. The user just quite often for a lot of this stuff just needs to touch the fingerprint sensor now to log on to all this stuff. So sort of racking it all up, hopefully you should know why you should be using MFA on all your systems. You've got some ideas to avoid some common mistakes and pitfalls, and you're going to implement that robust authentication system across everything. And so, thank you to the Chicken crew for picking our talk, Ray Rat Conference. Thank you all for attending this morning. It's day 2. I know a few people were out last night. It's great to see you. Well, I assume there's people in the dark out there, but here's some laughs from time to time. Thanks to some colleagues, past and present, who have given us ideas for the talk. It's not all just our hacking and our reviews. It has been a sort of a collection. So it's been great, Thank you all.
I am a super genius.